Hello, everyone. My name is Mikhail Vernik, and co-author of this article is Lyubov Oleshenkitsu. So we are from the National Technical University of Ukraine, Igor Sikorsky Polytechnic Institute, Kiev, Ukraine. In this article, I want to introduce Metaheuristic optimization algorithm usage in the recommendation system with user psychological portrait generation. We're pleased to be on this conference, on the 6th International Conference of Computer Science, Engineering, and Educational Applications. Introduction. Metaheuristic optimization methods in neural networks, they provide no worse results within the relative error of 10% or 1 or 2% more accurate than classical methods of optimization for recommender systems, which creates a new branch of recommender systems interaction with metaheuristic optimization methods. The objective of the research is to compare classic optimization approach with a metaheuristic approach for a recommendation system in recreation sphere by providing a proof of concept with increasing the accuracy for users' choice of recommender system events by using combination of metaheuristic optimization algorithm and building a psychological portrait of the user using neural network and factorization metrics. On this slide, you can see a metaheuristic algorithm and how are they displayed. So they are basically chunked into 4 main categories. So the first one, evolutionary algorithm, the next one, physical based algorithm, and the next one, swarm-based algorithm and human-based algorithm. All of those spheres are the mainstreams by now in the metaheuristic algorithm. So a quick introduction about types of recommendation systems. Recommendation system exists in 3 types. The first one is classical, and the second one is personalized, and the third one is more using machine learning stuff. So for the classical approaches, we use content-based recommendation system when you have some content actually, and you're recommended by it, or collaborative filtering when you have an object that's probably liked by a few people or users and you want to recommend to someone. And of course, you have personalized recommender systems, which are basically context-aware. Research tasks. So the first one was to analyze methods of metaheuristic optimization using for building recommender systems. Second, collect data from users of recommender system for conducting research. Third one, software method development for comparing the classic recommendation system and the proposed recommendation system using metaheuristic optimization methods. First was to evaluate the effectiveness of the proposed method of building a recommendation system. And the fifth, the main step, develop software for recommender system based on the proposed method. So, software implementation of the proposed method. For this technology, were used both cross-apply technologies like mobile, front-end, and back-end technologies, cloud technologies, mostly used .NET, SQL Server, Google Maps, Firebase, Azure, Python, Flask, etc. So there were more like 40 tables created to finally make it work. This approach and proof of concept, and you can see on the right-hand side with list of tables was developed database. For web and mobile technologies were used Microsoft.NET and React, Flutter, and app was actually installed and deployed to the Google Play and App Store. A deep dive and a short piece of code of neural network technology. So we used TensorFlow and Python. This small piece of neural collaborative filter of 2017 implementation, which were modified for this optimization approach. So the developed recommender system architecture. So we're gonna start from the left-hand side to the right. From the left, we have mobile application that will develop it, and we have a web application for psychological portrait. So in the very middle, we have backend.NET Web API, which talks with service, EPM LPMO, which is specifically for this algorithm recommendation system, which generate everything that we need. Everything else should generate the side logic of this So the Google Maps API, it's used for taking places, so where you want to go, like bowling, park, etc. And psychological portrait is generated by the technology of Cambridge University of Model Ocean. So proposed model for recommender system. I split this recommender system in 3 parts. The first part is factorization matrix on the left side, neural network on the right side, and optimization metaheuristic algorithms. We're gonna deep dive in a few slides a bit later about each one of those. Briefly talking. So research data. For the research data, user and event data are represented as separate data vectors, whereas the number of active users is 110 and the number of events is 5,370. So more than 2,000 events have been added by users in total. Second, more than 2,000 data on user actions such as time span or in particular page, invited people, selection parameters, psychological portrait were taken. For the output, we have more than 20,000 rows of data about users and their interaction in the system. This dataset can be presented in the form of 2 datasets for training and testing, where 10,000 rows are training and 2,000 rows are for testing. The basis of recommendations is user data recommendations. Can be any characteristic, for example, a constructed neural network of the psychological portrait of the user to create recommended list of invitation used to the users. In our case, it's a list of recommended events. So a bit more about recommended events. On the left side, you see a table for each abstract subcategory. So basically, there is an abstract tree of events. You have passive and active way to visit any event. And by abstract, I mean you have a sport gym, and you select here for which ranges it is applied, and you select for which moods it is applied. The next step for the neural network is to process those mood states. So instead of being simple binary 0, 1, it become more concrete. It will be between 0 and 1 value. On the left side, on the right side, you see the data of supplier companies. So those are companies taken from the Google Maps, which provide you the rating, address, created time, and basically the name, and to which abstract category a supplier film is connected. About the model Ocean and the user plan created events. So the model user is created for all openness, consciousness, extroversion, activity, and the narratism. So for each user, separately generated all of those 5 parameters, and they are applied to the events that you select. So on the bottom, you see the plan is created by users. So basically, there is a user who invites someone or selects something for him. As an example, the 5th user is about to visit stand-up at 12 a.m. and to finish it at 2 p.m. This is what is generated. On this slide, there is a presented developed mobile application of entertainment planner. This recommendation system on the left side, there are links to this application from the Play Market and Market and Google Play. On the middle, there is a visualization of the user's plan. So there is a menu bar and my schedule and recommended events that I would like to visit. About metaheuristic optimization algorithm usage. So the proposed recommendation system uses the narrow collaborative filter model with modification and optimization of the neural network learning process using 5 metaheuristic optimization algorithms. It uses gray wolf optimization, particle swarm optimization, whale optimization, and B and genetic algorithms, which interacts with the neural network as follows. First of all, the neural network is decomposed into a one-dimensional vector of levers of neural networks and levers of deviations. Basically, it flattens down the biases and weights in one vector. The vector in decomposed vector, the vector of the composite neural network will be called the generation. So the generation will be processed by metaheuristic optimization algorithms. Each of those algorithms will generate a new generation. So the first one, among the 5 generations, the best generation is selected based on the root mean square error of the final result. Fifth, the levels of neural networks, they are split back to the weights and biases. A short introduction about graphable optimization visualization. So it was taken from the scientist. From 2017, there was development of the behavior of gray wolves, and it was described in the mass model, which was applied as an optimization algorithm for different mathematical problems and physical problems. On the right side, there are a few formulas of particle swarm optimization and whale optimization algorithms. So TRMS implementation of the recommendation system. Stage 1, the event structure tree is created in the equation field. Stage 2, system user data is collected and analyzed. Stage 3, a set of metaheuristic optimization algorithm is applied. Stage 4, a personalized recommendation system is created with selection, events, and users. So a bit step by step about the stages. So vectorization metrics. In the left side, we have users, and the right side, we have events. Each user here, it has, besides the ocean model, it has its own 8 parameters like fun, relax, intellectual, sport, and 4 more. And the same parameters are applied to the events. Basically, this is how we match users in factorization metrics. If something is missed, so we just basically multiply it from the existing data. The recommendation system model. So everything starts from the data, from the user's data and events data. Events data are taken is a one vector and the users is another vector. So we split those data for the matrix factorization and for the neural network. We flatten those vectors, such as weights and biases, in one big linear vector, and for the matrix factorization, we just multiplied it. And for the neural network, we process it with ReLU activation lawyers or function activation. We process those 1 generations through 7 layers. And in the result, we got a vector, which we concatenate. And we calculate a score, which will be taken by mean square. And we take this best generation and apply this flattened vector to a bunch of metaheuristic optimization algorithm, which will generate a new generation, and we'll do everything the same again. So this process will be taken for 10 or 20 generations. About the research results. So for the classical approach, MLP plus backpropagation, it provides 76.68%. And for a proposed method, MLP plus metaheuristic optimization algorithm is provide 84.61%. With the most welcome and most well-known algorithm, particle swarm optimization provides the worst data, the worst accuracy, so it's about 44%. So the reliability and accuracy of the results have been provided by using a data set of 6,000 real events as a proof of concept of a proposed methods on the basis of the representative sample. An 8% increase in accuracy was obtained from the classical method to proposed. The results of the test show that the testing took place on the sample of data for Kiev city in Ukraine in about 6,000 events, which were obtained using Google Maps API. Conclusions. For the first time, it found first development this proposition of methods proposed by the authors. MLP plus MOAN improves accuracy of providing recommendations to users of the recommender systems, which better compare it to existing software solutions in the recommendation system field. The model for learning and optimizing the network is based on metaheuristic optimization algorithms, which in turn have advantages in solving specific tasks compared to accurate optimization methods. In particular, an advantage in the speed and the convergence, and the advantage of being able to avoid local traps depending on the task. This can be both minima and maxima. Disadvantage of using the proposed methods is time cost for data processing. Continue with the conclusions. The proposed software method uses as a basis a narrow collaborative filter with metaheuristic optimization methods, which ensures fast convergence of findings and a way out of local traps of the function, thanks to which the result of improving the accuracy of the user's selection of events by 7 or 8% when using the full set of more algorithm compared to available methods. Based on the received data, which in turn allows improving the accuracy of users' analysis, the proposed methods provides a reduction in complexity of calculation and provides greater accuracy than the classical implementation. The model structure of the proposed software, the modules of which implement the above-mentioned algorithm, greatly facilitates the implementation of the software product as a whole. The future development of the proposed method. In the future, based on the obtained results, can be created a universal approach of the self-developing recommendation system with a superpositioning optimization algorithm. Proposed method can change the classical realization of recommender systems development as well as applying new technologies to optimize neural networks. The analyzed evaluation results and comparison of the efficiency of similar solutions can be used for various applied problems where a choice of possible options is implemented. Thank you for your attention. If you have any questions, please email me on misha.vernik1@gmail.com. Thank you for your time.